Steve's Physics channel. I'm Steve, and today we're going to do a projectile motion problem where we're only looking at the first half of the parabola and the part that's going up, right? So in this case we have, you throw a ball up to a friend on a balcony who's 12 meters above you and you're standing 7.5 meters away from the bottom. We want to know what is the minimum velocity that you must throw it with. So go ahead, pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Hopefully that wasn't too bad. And the trickiest part to get started with this is to figure out what is the minimum velocity and what sort of angle are we throwing at, because it doesn't really specify. That's the toughest one, and this may seem intuitive, but in general the most efficient way to throw something that will get you the combination of the longest hang time and the farthest distance is 45 degrees. And it's at 45 degrees because if you go above 45 degrees you'll get a really long hang time, but you're not going to go too far. And if you go below 45 degrees, you're going to go farther, but you're not going to have much hang time. And 45 degrees is sort of the sweet spot where you're going to get the longest distance for the same throw. So if we use that, now we write down what we know about the problem, and we use that to start solving for what we don't know. What I tried to do first was I used final velocity squared is equal to initial velocity squared plus 2ax. In this case, we want to try and find the vertical component of velocity. So we're only going to look in the y direction, and the final velocity in the y direction at the top of its peak is 0. But we don't know what the initial velocity is, and so that's what we're going to solve for. We know gravity, and we know it was 12 meters above us for x. So we plug all that in, solve for the initial velocity, and we find the initial velocity in the y direction of 15.34 meters per second. When you draw the triangle, hopefully you know your sines and cosines, and you can figure out that using the sine function will allow us to solve this problem pretty easily. So in this case we set up the equation, the 15.34 from before is equal to sine of 45 times the initial velocity. Do a little math, solve for the initial velocity, and we get that it should be 21.69 meters per second. And because we're throwing at 45, we know that is the minimum velocity. And it's also the answer to our problem. Hopefully that wasn't too bad for you. If you do have questions, please leave them in the comments below. If you found this video helpful, please like, subscribe to our channel. And until next time, have a good day.